Good afternoon, good evening, or good morning, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. As always, we have a great webinar on tap, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will be able to access it later on demand. Following today's webinar, we'll be sending out an email that contains a link to access the webinar. And we are taking questions from the audience. So if at any time during today's presentation you have a question for our speaker, please don't wait, don't hesitate. Just use your GoToWebinar control panel and submit your question. And we'll take a few minutes near the end of today's webinar and go through the audience questions. And finally, also at the end of today's webinar, we are going to be doing a drawing for 3 Amazon gift cards totaling $50 each. So stick around, hopefully you'll be one of our 3 lucky winners. All right, with that, I'm going to go ahead and kick off today's webinar, which is Feeding the Virtual Patch Pipeline. Our speaker today is Cody Wood, who is the security engineer at Signal Sciences. Hey, Cody, how you doing?
How's it going? Thanks, Charlene. Yeah, doing great.
Awesome. Well, I'm going to put myself on mute and let you get to it.
All right. So yeah, we're going to be talking about the virtual patch pipeline. I'll get into what virtual patching is, kind of what it means to us as Signal Sciences. And so I'll just start off with, basic kind of intro stuff. So who am I? Previously, I used to work in earth mining operations, nothing really related to technology. It's only been recently that I've started working in application security. In my journey in application security, I went from white hat security, did some PCI sort of assessment stuff, worked at NBC Universal, Rapid7, and now currently Signal Sciences. Like Charlene mentioned, I'm a security engineer at Signal Sciences, so that's sort of a unique situation where I dog food our own product a lot. I both worked in positions like at NBC where I was sort of blue team and helping the business secure itself, but it's kind of interesting working at a company now where the product I use is actually the product I use on the daily basis. So I'm able to secure the company and both contribute to value in the actual product as if I were using them as a vendor. And mainly been trying recently to get better at Python and convert some of those skills that I've been learning over the years in Python to Golang. And a lot of our product is built on Golang, so we encourage that. And it's been a little bit of a struggle going from a scripting language to a more statically typed one. There's some of my contact information as well if anyone wants to follow up after with questions either related to virtual patching pipeline, Signal Sciences, or just application security in general. All right, so to start everything off, I'm just going to start with some basic application security challenges. Really, like it's what our industry is facing. How did we get here? Why are we going there? What problems are we trying to solve? Things like that before I get really into the meat of the presentation. So web applications are top priority for a lot of, well, I shouldn't say top priority. People are getting attacked via the web application layer. People are getting old legacy software that they're converting to REST APIs. A lot of different IoT stuff even has just basic REST API web servers on it. So web application attacks have obviously increased over the years. Security spend, though, hasn't really kept up with that. And it's probably been a fault of the whole industry, the industry as a whole. Legacy WAF has been traditionally very terrible at helping out with the web application attacks. So we've typically relied on dynamic analysis, static analysis, basically testing our code internally or attacking it in order to find all the problems. And we weren't that great at identifying even where we were being attacked, when we were being attacked, or even if we were. It was very hard as a security engineer in some of my previous roles to answer just a basic question. Are attackers attacking us right now, and where are they attacking our web application? I wasn't always able to clearly and safely answer that and really confidently answer that. And so the focus is sort of changing is because a lot more web application attacks are happening, companies becoming more concerned about it. There's still a lot of other priorities, but how do we get that priority of web applications to actually translate to dollars and budget and resources and things like that? So it's not like a small problem. Application security is a very deep sort of, glacial tip of the iceberg thing we got going on here. It's the same threats that we've had for a long time. SQL injection is not new. We've known about it for a long time. It still happens. You still see bug bounty reports on it. You still see major businesses that are exploited via SQL injections. Why have we not been able to solve a problem that's been a problem for 15 years? So legacy WAF, the basic approach was to do regular expressions. That usually led to production failures. That led to managing false positives. And that led to really a lot of businesses never making the decision to actually go into blocking mode. They were in a learning mode or some sort of monitoring mode in order to tune things and adjust rules. And so it was always a battle, and nobody liked WAF. And usually it was sort of a compliance checkbox, and we would just go in and make sure everything was okay, and then we would come back to it maybe 6 months or a year later, as long as it was kind of protecting stuff, or at least allowed us to check some boxes in PCI. So how do we change that? These problems extend way beyond like what legacy WAF has addressed. We have account takeover, you have forceful browsing, you have business logic attacks, things that don't look anything like an attack. These look like very traditional user activities, but they have malicious intent. How do you identify something that doesn't have script alert, that doesn't have a SQL injection payload? It's more of a coupon thing where they're abusing the coupon, and maybe they're brute forcing it, or maybe they're just adding a null byte in order to get free coupons. So any weird things like that, where it's more of a business logic thing, we provide the tools necessary to instrument those business logic endpoints, to understand what's going on with them, understand when they're being attacked and how they're being attacked, versus putting all of the onus on us internally and becoming adversaries of our own software engineers that we're supposed to be supporting. With dynamic analysis and static analysis, we're often in an adversarial relationship with engineers of us finding everything that's wrong with their code. And we would kick over reports to them. Look how bad your code is. Like, this is really terrible code. Fix this, fix that. If you guys don't, I'll be really mad. And that was sort of the traditional application security relationship. And to have that going on internally is a major issue. But if we sort of focus on the edge, like, where is everyone actually attacking us? What do I care about? Where are people maybe stumbling upon an error that could become a security issue? So how do we instrument those things, and how do we all look at the same piece of information and communicate to each other? I think this is a risk. Can you explain to me why it might not be? It's very much a better relationship between security people and engineers. So that's sort of where our product falls, is the next gen WAF or RASP space. It's really designed to just bring security to the forefront. How do we do it without disturbing production? How do we do it without causing tons of friction? How do we make not only the security organization successful, but operations and development? How do we all work as a team to basically reduce risk in the application and understand actually where we're being attacked? And this is our sort of whole pitch. It's any app, any attack, and any deployment model, really, any DevOps tool chain that we integrate with. In any app, it's agent module sort of infrastructure. So it made it really easy for us to build modules for different types of web services. This could be IIS, Apache, Nginx. This could be any of the PaaS platforms. This could also just be rolled into something like a reverse proxy. So we've supported many different types of deployment models, very frictionless, not a lot of setup required. Usually it's like add the repository in, app get install SigSci agent, you're good to go. So that's really, we wanted not only to be great at like protecting things, but like the deployments. Sometimes those deployments, if they take weeks, everyone's already burnt out by the time they have to use the tool. If it takes 2 to 4 weeks to do a WAF deployment, I'm not gonna at week 4 start to actually configure and go do things. It's really frustrating to do that. So have a deployment just really frictionless, and you can work development teams like, hey, add these couple lines, we're in line, we got tons of visibility, can you guys do that? Everyone would be on board with that. So any attack, as well as it's injection attacks, it's cross-site scripting, command execution, SQL injection, attack tooling, and then anomalous behaviors. Because really, it's not just attacks that are important. Like, just by nature of being on the internet, you're going to be attacked. Somebody's going to send cross-site scripting to you. Somebody's going to run an Nmap scan. Somebody's going to run a NICTO scan. You're by nature of having a resource on the internet, you're going to get attacked. And so how do you sift out that noise, the nature of just being on the internet, from something that you are actually concerned about? How do you look at those things that are unique to your application? Maybe you're confident in like not having SQL injection. Maybe you use no SQL, and so you use it in a different part of the site, and maybe that doesn't even apply. So how do you focus on just those things? And that's where the attack signals, also the anomalous behaviors come in and really help augment things like application distributed denial of service protections. Those are more on the business logic side. It could be a particularly resource intensive REST API call, maybe something that calls a regular expression. Those can all be set up like where if somebody keeps continuously hitting it, it would exhaust the resources of the server. So how do we protect against things like that? And then on the integration side, like we're protecting it, we're seeing it. How do we get people to actually triage this information and do something about it? And everything that we do in our dashboard is REST API driven. So if there's some dashboard you see, if there's some request you see, there's some API call driving that. And so that's helped increase our adoptability, or like our adoption in internal organizations where maybe they don't want to touch the tool, maybe they never want to log in. If we give them an API token as security engineers, we can allow them to write their own scripts to do whatever they want to pull that information directly out of the dashboard and integrate to any of the tools that they want. We also have some great one-click stuff via Slack, Datadog, PagerDuty. Those are going to be basically an events feed directly out to those types of tools where it's something meant for like incident response. If an event happens, it's something that you need to react to. That's something you want to get in Slack. That's something you want live and you want to be able to respond to quickly. All right, so that's sort of a summary, like where we fit into the WAF market. Really, we're trying to supplant some of the legacy WAF approaches because obviously they have not been effective. We're still vulnerable to the same types of stuff. So this is our kick at it, is how do signal sciences approach it and how are we different? But specifically, I'm going to be talking about virtual patching today. And it's come up often with our customers as like we want protections, like what is a virtual patch? Can it protect certain things? Like how does it protect it? Can you guys protect against these old WordPress things? And so I really want to put this presentation together to help baseline and communicate like what is virtual patching, how is it supposed to be used in the industry, but really like how could you use it if you're not really running up to par with maybe with all the best practices. How do you protect yourself even if you're not in that great as a scenario? And by the end, I'd like everyone to walk away with a demo of us basically going through how to write a request rule, a blocking request rule for a specific CVE. All right, I'm going to talk about some code names, some internal stuff. This is sort of a behind the scenes kind of sneak preview. We internally called it something, the virtual patch pipeline. When we were writing the CVEs, we weren't sure which ones to identify, which ones to work on. Do we wait for customers to report them? Do we go back catalog a whole bunch of CVEs for the last like 5-10 years? So we had to make a lot of decisions initially, just like how are we going to approach such a obviously like kind of tough problem in the industry? How are we going to approach it? What would we do different? So I've like pipelines are sort of a cliche thing I've noticed, but really it's just automating some steps that normally a human would do. So that's all I did, is I did what I would normally do as a person, and then I just try to automate as much as I can using scripting initially, and then eventually moved into something. So that's what I'm going to talk about today. We're internally calling it just Jarvis. It's just threat intelligence, but specifically for our needs, specifically for delivering new virtual patches directly into the product to help know ahead of time when our customers need them versus them having to come to us and ask for a CVE virtual patch. Also going to, behind the scenes, just the methodology that we use. We triage these, how do we build them? What things do we look at? Like what things could we maybe look at better? And so I'm kind of hoping in the questions and answers, I actually get some design feedback and some questions about, look, why didn't you try this method? Why didn't you try that? Or have you tried this? So I'm really asking feedback on this as we built this system, but it's sort of our MVP and we want to see where it evolves from there. And then by the end, also just to build your own. How do you do this by yourself using our product? So before I go on much further, let's talk about like what a virtual patch is, or really what it isn't. I like to just refer to it as duct tape. Like it's great, it works. I've duct taped tons of things. It holds things together. It's really great. It's just the sun beats down on it, breaks it down. Duct tape is not a permanent solution. It's always temporary. As it breaks down, you'll continuously need to patch it. That's very similar to how virtual patches work. They're a temporary thing. if they're not correctly implemented, there could be bypasses or holes in them already, and those are things that you'll have to keep aware of. What if a new version of it comes out and there's a new type of exploitation of a older CVE? Are you going to go back and update those things? What if that breaks production? So there's a lot of consideration where a virtual patch, you're really just looking to buy some time, and that time is going to be contingent upon your business conditions at your organization. If you're patching once a year, you might need to buy a year. Hopefully that's not the case. That's on the more extreme side. But patching is what fixes it. Patching the server, patching the code, doing something to actually fix it is really what needs to be done. The virtual patch is giving you the protection out front right away so that you can buy some time to work on that patch. But they should not be used in the long term as really like attack intelligence or anything like that. That's not really the recommended way. It's mainly based on public information. These are things that like we have to wait for attackers to already be aware of them, so they're still like behind the curve there. And any bypasses, you're going to have problems like instrumenting things to detect those and recursively looking back. So there's a lot of entanglements and problems with even just doing virtual patching at all. Like the best way is just you're patched all the time. Like that's obviously the best way, but real life business conditions are never like that. So how much time does your organization need? So that's something you want to identify pretty early. It might vary dependent on what type of patch you're doing. Is it a web service versus code? Maybe code takes a day and the web service takes a month. So things like that you're going to want to be aware of so that you can get ahead of the curve, that when these come out, that you know a timer kicks off. We're going to put this virtual patch in place. It's going to protect us, but it's not forever. We're going to do it until X timeline. And using our expirations and things like that, you can also do that via the rule. It forces you to think that way, where that patch needs to be in place before you consider removing the virtual patch as well. So this is a diagram I put together recently for a blog post. This is the probably what the virtual patch line was like maybe a week ago. And this is really initially how it all started. So we can see we have here, that's the AWS code build logo. So we just run a code build job. All it is it used to be Python. Now it's just a Golang app. We really run it basically as a script. And that code build job will kick off every 6 hours. So really you can think of this as a cron job. Like it used to exist in Jenkins. We've kind of moved it out to code build. It's a little bit more mature as far as like the integrations that we can use when we want to do stuff in our tool set. So we'll hit this API endpoint. It's called CVE search. This is a open source product or tool, I guess you would say, that gathers information from NVD NIST, basically anywhere that has CVE information, and then aggregates it all together. And they have a publicly available API that we use to look up things like exploit DB or Metasploit or packet storm. We're basically looking for exploits that exist in a CVE that are publicly known. So really what we're trying to find is a proof of concept. And so by hitting that search, once you've identified that criteria, we'll also do an additional search against GitHub. Because another pattern we've been seeing with CVEs is that when a new one will come out and somebody develops a proof of concept exploit, they'll often just make a new GitHub repo. And these CVE search tools and these CVE databases will not often be aware of just these random GitHub repositories that contain exploit code. So we added some augmentation there. We also do some like Twitter searching just to find out like what other CVEs are out there, just a list looking for CVE types and things like that. And so that helps us keep ahead of the curve, like what CVEs are out there, what's available, how do we filter them? There's hundreds of CVEs sometimes that come out at one shot. And so how do we sift through all those and find out what's a web application one with a publicly available proof of concept that's like remotely exploitable via HTTP? So it's a very specific subset of things that we can protect against. So we can't protect against like local Linux exploitation. Like that's not at the stack that we're in. It's still things that only a WAF could really protect you against, which is things at the HTTP layer. So I did want to announce or show today, this is what it is now. So I've been doing this probably like a year or so now, just on my own. It started out as a hobby project on the team, but recently we've hired two more of similar positions, security engineers. So we had a problem of now it wasn't just me triaging these things and developing these things. We needed to have an actual like collaborative platform to do all this in. So we kept a lot of the same stuff. We kept the code build job. We still hit the CV search endpoint. We still look for these sort of filtered things. The filters have been getting a little bit more complex and better so that we don't have to respond to so many things. And we also added, in addition to our Slack channel that gives us updates on how well it's running, how many we're checking, which ones are valid, we're actually pushing some of our metrics out to Datadog as well. Just so over time, we can say this year we've analyzed 1,500 CVEs. Of those, there were 10 valid CVEs that we developed X virtual patch for. And it gives us a lot of telemetry on how well we're doing, how often we're doing it, and really just resource kind of provisioning. And then in addition to the GitHub, we're actually using GitHub to make triage tickets now. So instead of doing all of our Slack-based triaging, where we would have a CVE link come in to our Slack channel, we would triage that. We'd say like, oh, is this something we need to worry about? Can I build a rule for it? How long would it take? We're actually kicking those out to GitHub tickets, and we have this templated ticket that kicks out all of these different CVEs that we need to triage. And that makes it much more collaborative for us internally to get together and work on something. You guys still there? Okay, good.
Yeah, okay. Yay,
All
you're
right, sorry
back.
about that.
That's all right. Making sure you were still alive there.
All right, I am back here. All right, so what is that stuff I was talking about triaging? Like what is triaging? This is something that I would do personally. I used to do it in the Slack channel. Now we have GitHub tickets. Really, it's just find the CVE. We basically like search our code base for find the CVE. We copy paste some of the old templating, and then we replace all those things with the new CVE code. So it's really easy for us to actually put this directly into the product. So I'm actually going to show where our templated rules are in there, but not only on the triage side have we been able to consolidate a lot of that process, but our team is actually able to deploy these virtual packages directly to the product. So it's hours between us triaging, finding a CVE, and actually building a rule and pushing it directly into our own product. And so it's really cut down the time and increased our velocity on being able to do these things, where our response time we don't have to wait for a release cycle. I can push it within hours of discovering a CVE, writing a rule, and then actually pushing it directly into product. And so I just wanted to show just kind of what that looked like. This is basically all we do. It's not a ton of overhead. I don't need to be like a really great Golang software engineer. It's mostly like a bunch of copy pasting, moving stuff around, doing some internal testing, and then we're ready to go to have that out into production. This is another question I've been asked is like, well, what do you guys watch for? Like once you release these CVEs, are you watching for like unique payloads? Is there anything cool that comes out of them? What about false positives, false negatives, things like that? So right now, I haven't quite figured out how to automate this really great into that sort of pipeline tool. I'm a big fan of Jupyter notebooks, using Python and things like that. So what we have is a set of Jupyter notebooks that will actually query our customers' hits on a CVE, and it will tell us what customers enabled that CVE. So after we've deployed one, after it's available in product, after we've sent a release notification to everyone, hey, new virtual patch is available, we also watch who enables it, when they enable it, what site was it enabled on, how many hits have they had in the last day, 3 days, 7 days. And then we also, after that, depending on the nature of that virtual patch, we'll look for unique payloads. And so we start to see things like crypto miners, or we start to see things that are hosted on Payspin and they're doing a curl request. So we get a lot of like very unique kind of cutting edge threat intelligence by implementing these, and then also watching how it affects our customers. And so it's sort of this full cycle, and we get a great feedback loop where if any false positives come up, we're able to address them very quickly. We're proactively looking for them. We do highly recommend our customers start out in a signaling mode of sorts, just to make sure that there is no crazy sort of scenario where we're signaling on a bunch of traffic on the site, and then after that, enable the blocking mode. So I just want to kind of give a sneak peek of all the work that we do internally to make sure that the work that we do is good, that it's something that you can rely on, it's something that you can be confident in that works really well. All right, so now for the demo part, a little bit ahead of schedule, which is good. So I'm gonna do a demo today. I'm gonna actually be going through this CVE 2017-12615. It's an Apache Tomcat issue, came out obviously in 2017. It's very simple, very rudimentary. Basically, there's an exploit where you could put, and put is a HTTP method like get or post or patch. Put though will just like put a file on a server. So apparently in Tomcat, it just didn't really care where you put stuff. So you could just put a Java server page file on a Tomcat server, and then you could totally run it. So what I've set up today is I have a Docker container. It's running Tomcat. It has our agent running in reverse proxy mode on that container. And so it's vulnerable to this issue. I'm going to go through the process of exploiting that vulnerable container. And then after that, I'm going to set up a very rudimentary request rule that doesn't even use our virtual patch rules. And it's going to show that it's blocking it. And then we're also signaling on it. So let me. All right, like I said, we got localhost here. It's just on 8081. It's Apache Tomcat 8519. So obviously a little bit out of date. You can see here if I just generate a 404, it's just a default Tomcat install. I will see under this, this is what our corp dashboard looks like. We're going to look at the agents page, and I can see I have a Tomcat agent running right there. So that's that reverse proxy agent I was talking about, running on a Tomcat service that's running in a container on my local machine. All right, let's review the exploit. So this is basically the part where the virtual patch pipeline would have seen this CVE. It would have said, okay, it's Apache, so it's web. It's remotely exploitable. It's of a serious nature that we care about, and we would have got a alert on this, and it would have said, hey, you guys need to triage this CVE. So the first thing I would look for is the POC, the proof of concept. So this is the proof of concept for this particular vulnerability. You can see it's just a put, and it's very simple. It's 1.jsp, and they're adding in some JSP template there, which is out.println hello. So in this case, what the expectation is from an attacker's side, obviously they don't care about printing println hello. They probably do something like Java exec command or something, and it would give them a reverse shell back to their machine. In this case, this is enough for us to go off of to build a protection for. So we have the put, which is really unique, and then we also have the .jsp. So it could be a totally typical thing for your application to have put requests to the Tomcat server. That could be totally normal. So that's why we really offer the signaling, and what I'm going to go through today is just signaling, and then you understand, is a put request of a JSP file normal for our users or our internal stakeholders for the application? If it's not, we could probably safely block it right away, and then maybe later whitelist those individuals to do this until we can get a patch in place. So this is the one I'll be going through. We've identified the POC, I have the agent connected, and then I have this rule sitting here, but I'm going to go through the actual exploit first. Hopefully this isn't too small. So it's just a curl request. You can see again, it's a put method, and I'm hitting 8081, which is that Tomcat service. I'm just going to call this one devops.com.jsp just for demonstration purposes. And in my case, I'm going to make sure it's actually going to exploit something. I'm going to do a print line of 1 + 5. So I want to make sure it's actually evaluating this stuff. It's not just returning a string or something like that. So I'm going to run that. We can see we actually get back a 201 created, upload completely sent off. So if I were to make a request to that endpoint again, devops.com.
While Cody's doing that, I do want to remind the audience that we do have plenty of time we're going to have plenty of time for questions. So if you have a question for Cody at any time during the presentation or the demo, just go ahead and use your GoToWebinar control panel and submit your questions.
All right, thanks, Charlene. Oh man, you're killing me here, Smalls. All right, so I'm expecting actually a 6 to come back. I'm just gonna roll back up to where it was working before. Right there. So this is the expectation. I'm not sure what's going on, but basically I make the curl request to test.jsp, and then when I make the subsequent, oh, I gotta actually make it to that. Okay, I get it. There we go. So I get 6. So that was actually evaluating that print line, that 5 plus 1. So first I made that put request here, which placed the devops.com JSP file there, which does out.println 1 plus 5. And when I make a subsequent request to that endpoint without the trailing slash, it will return the 6. So that basically is remote code execution. In that case, I would do a reverse listener or something like that. So let's kick over to the actual rule that you built. So this is very rudimentary. This is obviously something that you probably want to iterate on, maybe change up a little bit. We're actually going to do, you can do like a path like star.jsp. We could also do like contains JSP, just as simple as that, or even .jsp. So really, I just look for something that's unique. I know it's probably going to be a JSP file. Maybe Tomcat takes other types that you need to do some further investigation on that would cause a vulnerability in your application. And then we're also looking for the method equals put. And you could look for certain user agents or no user agents, but initially you'd probably just want to start with just adding a signal. So you can see here I've done add a signal, and before the call I just did an add site signal. So in our product you can add any custom one you want. So in this case I added this CVE one. I'm going to go ahead and enable that, but I'm also going to actually enable blocking as well. So this is going to give me some visibility when people are trying to exploit this, and it's also actually going to block those types of requests. Basically any put method to a path that contains JSP. So you guys can see like it's probably, if .jsp is a common thing that you see in your application and put methods are done towards that, you might want to do a signal exclusion or exclude that or whitelist it or something like that. But in this case, it's enough to get started to understand where you're being attacked or where the normal behaviors are. And so I'm going to switch over and make that same request again. So that's this put request. We'll just do test.jsp this time. Oops. 406 not acceptable. So we see that here, that is our block code. So instead of a 201 content created where we uploaded the file, it actually is just going to block that request. And at least in this case, you would also be able to see when people attempt to exploit this, what was the name of the files that they're doing. So even from an incident response perspective, you'll have that visibility. Okay, we're after the fact, we were too late to get the virtual patch out. We were too late to actually get the patch out. How do we say where we're currently being exploited? So you can keep an eye out for those kind of JSP endpoints where people are accessing them. So it helps on both sides, like blocking it from ever happening, but also keeping track of it maybe after the fact of an incident. And so I'm just going to recap one more time. This is what the rule looks like again. And this blocking is something I when we do stuff internally as security engineers at our organization, we very often wait at least half a day before we implement any type of blocking. And we'll set a signal and we just watch for it. We just watch for weird behaviors. Quite honestly, we hope we don't see anything and that we can move safely to blocking because there was no false positives. But if there's suddenly a spike due to misconfiguration, that's something you'd rather find out via a signal than you would via a bunch of block traffic. So that wraps up the demo portion. I'm going to move on to questions and answer. Well, my answers here.
All right, so let's go ahead and get started with the question and answer period. Just a quick note, reminder, if you have a question for Cody, please go ahead and use your GoToWebinar control panel. Okay, first question, are there any CVE attacks we should care about even if they don't affect our systems?
So yeah, that's a great question. Is we often recommend that you enable virtual patches or CVEs only when you have that certain type of technology. And the reason for that is if I'm inundated with CVE alerts and it's saying that somebody's trying to exploit Tomcat and somebody's trying to exploit this, but I don't have any Tomcat servers. I don't have any Apache Struts servers. I don't care about it. Like it is interesting to see like there's attackers hitting your site and they're trying, but like that's not really that interesting because they're not targeting you, they're targeting the internet. And so you're just picking up static or noise from the internet. And so in my opinion you really shouldn't enable a CVE unless you're actually protecting against that CVE. Like a WAF isn't really meant to be a threat intelligence tool or a log kind of analyzer. It's meant to be there as your to know when you need to react to a web application security incident, to know what information is in those, and to also augment further so you can gather more information. But it's not really like, if it's something you're never going to care about, in my opinion, that's just more noise. Security teams are inundated with alerts and all sorts of data that we can't just as a person process. And so when you add more into the mix, I feel like it really convolutes things. And so when our approach internally at Signal Sciences is to only focus on things that are actionable. And those are really the only things we care about, is stuff that we can action on. And then we are collecting some of the data just to have it in there, but we don't set up alerts for it. We don't set up thresholding. It's very laser focused on what technologies or attacks affect our business.
All right, great. So let's see. We have one more question here. So I do want to remind the audience, if you got a question, now's the time to get it on in and we'll get to it. Okay, so this other question, what is an appropriate amount of time for a virtual patch to be protecting? You said it's not a forever thing, right?
Right. And that's why I go back to temporary. I just want to temporary. And it is contingent on your business, but I would say 90 days. Like that in my head, I never want to have a virtual patch out there that is protecting an unpatched system for more than 90 days. And so that's my number I throw around. I'm glad to hear any feedback on it. That's too long, that's too short. But I feel like for most any business, small or large or whatever, if you are really great at what you do and you set a 90-day, you'll be crushing your goal and you'll have a new one because you're doing it in 10 days all the time. You set a new goal. If it's 90 though, it gives people like time to think about it. They got 3 months, especially like bigger businesses and the enterprise businesses we deal with. 90 days is a very typical sort of time window, but anything past that, I strongly advise against. If you're using it past that point, virtual patching is not what you need. It's not what you need there.
Okay. All right, great. Okay, while we wait to see if we get any more questions in, I do want to remind the audience that today's event has been recorded, so is being recorded. So if you miss any or all of it, or if you just want to watch it again, you'll be able to do so. We are going to be sending out an email later on that contains a link to access the webinar on demand. The webinar is also going to be living on the devops.com website. So if you just go over to devops.com, type in /webinars, and it should be right there waiting for you in the on-demand section.
And okay. Charlie, it looks like we did get a question, but I'm not sure I quite understand the context. It says, how do I leverage collaboration?
Yeah, Stan, if you could elaborate a little bit on that question, I'd be more than happy to answer it for you. So while we wait to see if we get anything else from Stan, I'll tell you what, why don't we go ahead and do our drawing for the 3 Amazon gift cards. And Brian, my producer, I know I need to send you these names, so I will do that. But our first, let's see, our first winner is, let's see, Catherine Spence. Congratulations, Catherine. And our next winner is, let's see, Shiva Raja Galopan. Congratulations, Shiva. And our last winner is Kevin Dobert. Congratulations, Kevin. Congratulations to everybody. And let's see if we got anything else from Stan. I didn't get anything else from Stan. So I guess if we don't get anything in the next, I would say 30 seconds or so, then we'll just go ahead and close it out. But lots of really, really good information, Cody. Thanks very much. Great
Yeah, I
presentation.
appreciate the time, Charlene. It was
Yeah.
great going through this. It's great to talk about what we do internally. Hopefully the behind the scenes stuff wasn't too kind of confusing because I know it's a lot of stuff that we just work on internally, but I really wanted to share it and like really start to get the community to understand like what it is we do behind the scenes, because sometimes I'm not always confident it's the right decision. I love feedback on how to make it better, how to improve on it, and things like that.
Awesome. 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 All right. Great. Well, I am going to go ahead and close out the question and answer period since we didn't get any more, but I do want to thank the audience for giving us a listen today, and to Cody for giving such a great presentation. And please, guys, take a look at the devops.com website under the webinar section, not only for today's webinar, but also for other webinars that we've done in the past and that are upcoming. Hopefully there'll be 1 or 2 that pique your interest. But for now, I want to thank everybody for joining me today. And this is Charlene O'Hanlon, and I'm signing off, giving everybody 18 minutes back in their day. So have a great day, everybody.
All right, thanks again.